I'm going to revise it again. So what is a grammar? So similar to our analogous to our normal natural language grammar, natural language grammar. So formal language grammar also is a set of rules. Okay, so you construct strings following these rules. Okay, so you get a language. So remember, it is a set of rules. So it goes like this. So grammar is used to generate a language. Okay, grammar is a set of rules. It generates a language. Okay, and the language is an input to an automaton or to a machine, any machine, finite automaton or any machine. So this language is accepted by the machine. So you design a machine that accepts your language. That's what we did in first unit extensively. So we designed finite automaton that accepted our language. So you were given a language and you were asked to design an automaton that accepts the language. So this is a hierarchy. So grammar is a set of rules that, so you follow the rule and you generate strings. Okay, you have a set of rules. You know what are the symbols that you have to use. Okay, and with the symbols and with the rules, you start generating strings. So all possible strings that could be generated out of this grammar constitute a language. And after you have a language, you can design a machine that accepts this language. Okay, so this is a process. And the set of symbols for the machine, since it's the input, language is an input, you call the sigma or sigma asterisk as input symbols. Okay, so this was input symbols for a machine because you give it as input, right? Whereas grammar uses the symbols and it generates strings. So we call these symbols as terminals in a grammar. So the output of a grammar, the output of using the grammar will be different combinations of these terminals. Different combinations of these terminals will generate you strings. Okay, so this is called as terminals in grammar. The same symbols, we called it as input symbols in DFA or NFA, in an automaton. Okay, so this is the introduction. So it's a syntactical rule. Okay, so for conversation, similar to, it's analogous to rules for conversation in natural languages, like you say a sentence should follow a subject, verb, object pattern, something like that. So it's a set of rules. So Noam Chomsky, he gave a mathematical model for this grammar. Okay, so the rules are called as production rules. It produces strings. So the rules followed to produce strings are called as production rules. They are used to generate strings. Okay, so this is one valid production rule. This is a non-terminal or a variable. Okay, non-terminal or a variable, and these are terminals. 0, 1, 2. Now this rule means whenever you see that variable digit, substitute it with either 0 or 1 or 2 or 3, etc. Okay, so 0 or more occurrences of any of this. Okay, to define like 0 or more occurrence, in case you want a sequence, you can give something like this. Okay, so substitute the variable digit with 0 or more occurrences of one of these symbols, one or more of these symbols. Okay, so that is how we define rules. So this was an example, the digit was an example rule. So we saw all these are symbols, 0, 1, 2, 3 are symbols. So these are called as terminal symbols. So these are called as terminals. Okay, and the variable where you can substitute. So it is called either as non-terminal or a variable. Okay, so this is called as a non-terminal or a variable. What do you mean by non-terminal? You cannot have it in the final string. So non-terminal will not be present in the final string. So non-terminals have to be substituted. They have to be rewritten in terms of terminals. How can I rewrite a non-terminal in terms of terminals? I have to follow this set of rules. So I use this rule digit. Digit can be, whenever I see digit, I can replace this variable digit with one or more occurrence of any of these symbols. Sorry, 0 or more occurrence of any of these symbols. So a final string will have only non-terminals. The final string will not have variables in it. Okay, so this is the process in which I construct strings. So I use the rules, I use the symbols, and I I have to create or generate strings. So set of all possible strings that could be generated following this rule is called as language. This set of all possible strings that could be generated is called as a language. Okay. Now again, for the grammar, this is a formal definition. So in case you're asked a formal definition for a grammar, you have to represent it using this 4 tuple having 4 elements. Okay, 4 tuple. N, T, P, and S. See, the symbol N and V are used interchangeably for non-terminals. Okay, N or variable. It's also called as a variable. It's also called as a non-terminal. So in the following slides, N or V will be used interchangeably. It's called as non-terminal. So non-terminals are variables. You can't have the variables in the final string that you generate. It has to be substituted with terminals. Okay. So terminals are analogous to input strings that we have seen for automaton. So it's a set of symbols. So terminal. So when you when you define an alphabet, so sigma is an alphabet. So when you say 0, 1, so all alphabets, okay, all sequences of alphabets, okay, so they are called as terminals. Okay, so 0 or 1 is a binary alphabet. So 0 is a terminal, 1 is another terminal. Okay, so you can create combinations also. They are also called as terminals. So in case you consider 0, 1 to be a valid terminal in your string generation, you have a rule that has 0, 1 that is also a valid terminal. Any combination of input symbols or the alphabets, any combination of symbols in the alphabets are called as terminals. And your final string that you generate cannot have non-terminals. It can have only terminals. Okay, and there is a special non-terminal that is used to start the grammar, or that's used to start your derivation. So that's called as a starting symbol. So you have to derive. The derivation is a process of generating strings from grammar, using grammar. Okay, so the starting symbol is a place where you start. You start with this symbol and then you expand it. Okay, so it's a special non-terminal symbol. Okay, again, it belongs to the set of non-terminal symbols, and you start your derivation from this symbol. It's a starting symbol. And P is a production rule, the rules that you follow to convert or to derive strings following grammar. Okay, so the rules are called as production rules. They are of the form alpha tends to beta, where alpha and beta are strings, and alpha and beta can have both non-terminal and terminals. Okay, so that is why you see N union sigma over here. So alpha and beta are strings, and these strings can have both non-terminals and terminals. Okay, so this is a formal definition of grammar. So it's defined by 4 elements: non-terminals, terminals, production rules, and starting symbol. Okay, so non-terminal, you can represent it by N or V. Remember, you'll see V also in the following slides. So it is valid. You can represent a non-terminal by N or T. You can represent a terminal, N or V, and you can represent a terminal by T. And in some places, some books, they have used sigma. So sigma is also valid. Okay, and production rule is represented by P, and S is a starting symbol. Okay, and whatever we saw, we are going to see some points on terminal and non-terminal. Terminal are represented using small case letters A, B, C, etc. Okay, and so terminals will be part of the final string that you generate. Okay, so they will be part of the sentences or the strings that you generate finally following a grammar. So non-terminal symbols are denoted by capital letters. Very important. They cannot go into the final string. They have to be replaced or rewritten. Okay, so they take part in the generation of the sentence or strings, but they cannot be part of it. True. Okay, and they are also called as variables. So they are represented by N or V, non-terminal. Okay, so this is an example of grammar definition. Listen, so this is G1. So I define G1. These are my production rules. Production rules. Okay, this is of the form alpha tends to beta. So you can see S, A, and B are the left-hand side alpha, and this A, B, small a, and small b are beta. Okay, so these production rules P1, P2, P3 are the production rules. Okay, so I'm trying to define the formal definition for this grammar G1. So non-terminal, terminal, production rules, and S. So production rules we have seen is a set of P1, P2, P3. It's a production rule. S is a starting symbol. So I should start with this production rule. I should start with S and use this production rule first always. I should start with S. So this is a set of non-terminals or variables. Non-terminals are variables. It's in capital letters, and these are my symbols. Terminals. Okay, so these are terminal symbols, non-terminal symbols or variables, set of production rules, and this is my starting symbol. Now, how do I do derivation? Last class we saw derivation can be done in two ways. You can do it in place expansion can be done, or you can use a parse tree. These parse trees are extensively used by compilers. Okay, so parse tree, how do I generate? I know I have to start with S. Okay, I'll start with S. Okay, so S can be rewritten using this production rule because only P1 has S. Okay, so I can use A, B. Okay, so in the place of A, what do I do? I can write A, right? Or here I have to write a B because it has only one rule that says A corresponds to small a and B has to be substituted with small b. Okay, so my string would be AB. This is how this process is called derivation. Okay, so this is called this process of generating strings using terminals and non-terminals, following the production rules. This process is called as derivation. And in-place derivation will be something like this. I'll start with same S, AB, and A I'll substitute first, then I'll substitute B. Okay, so this is how I do derivation in place, and it's a parse tree way of doing it. So this process of generating strings is called as derivation. Okay, so these are the basics of grammar. We should understand all the elements of grammar. What are terminal, what are non-terminal, what is a production rule, what is the starting, what's the use of starting symbol. I start with the rule that has, I start with S and I use the rules that have starting symbols. Okay, and then I try to derive using other symbols. It's not mandatory to use all production rules in generating each string. You can use any one string. If you get all non-terminals, okay, you can stop generating it, right? So there are many ways of generating using the production rules. It's not mandatory that you have to use all production rules in generating a string. Okay, you can use a subset of production rules. The only condition is the final string should not have any non-terminals. All variables or non-terminals should have been replaced with terminal symbols. That's the only condition. Okay,